Hey there YouTube, it's PD Two Finger, and this video we're going to be going over how I like to bias jfets. I'm not a pro tech or expert, so this video is just for reference. It's just the way that I do it. I do it like by the book, but I also do it to ear. We're just going to be talking about biasing jfets. So if you're going to want to railroad me or talk about how I'm wrong or an idiot, I would encourage you to take that negative and turn it into a positive and make your own video on biasing jfets. So this weekend we did a obtuse boost, which is a full tone fat boost. It's a jfet. There's 4 of them. There's only one bias control, and they don't have any information anywhere in this document saying you're trying to adjust the trim pot until you see 4.5 volts or half your supply voltage on the drain of Q1 on your multimeter. They don't say that anywhere. It should say it somewhere in here on the schematic, or maybe just in this section over here. But what they do tell you is a 3362P type. So when you're buying your trimmer, now we need to be aware that there's more than one type of trim pot. So let's take a look at that. I looked it up. Apparently the 3362, there is this one. This is a 3362 type. This one is a 3362 type. You see that the legs are triangulator. They make a triangle. And when you turn this, this would be the effect of, it has a dead spot in the bottom of the shape of pi. So you can turn it from like here all the way over to there and back. So if this was if it was a 1K pot, or let's say it's a 10K. If you started here, it would be 0, and you went all the way around, it would be 10K. Same thing with this. And this is the type that you see more often than not. You won't have to worry about the multi-turn or the 100-turn, but we are going to talk about them. So this is the 100-turn multi-turn. You will notice the little brass screw on the top, and also that the connection points are in a straight line. So you can bend those. You can bend those around and make it fit in the triangular slot, but they usually will tell you. They will say, in this pedal, like the Maestro sample and hold, the FSH1, they will say you really don't want to get a 1-turn trimmer, you want to get the 100-turn, because it's going to be much easier to get it to bias right at the specific point where they need it, where with the single turn, it even like putting your jeweler screwdriver in there and just nudging it, it'll often jump up a real lot of numbers. So that's the difference. And you, like, again, if you're pedal building, you really don't need to worry about the multi-turn trimmer unless they're bringing it up. Unless they bring it up and say, so don't worry about it. If you bought a trimmer and you think it's wrong, more than likely you got the right one, especially if it looks like this or looks like this. That's going to be just fine. Now, when we're talking about the circuit board, there are options for, at this point, it's easier to get the surface mount technology version of this jfet than it is the through hole. So we're going to talk about that. And if we look, we'll see this company has wisely printed this circuit board and given us options for both. Here's the through hole. There they are, 3 in a row. And then this little pattern here, that's where you solder up the SMT version. So taking a look, I've got some images of an SMT jfet. We'll see here it's labeled GDS. So it looks like this would be our this up here. See the S over here by this one. There's the see, now my mind's going blank. What does the GDS stand for? Drain, source, and gate. Here's our gate.
Gain.
Gate.
Gate.
It's gate. Here's the gate. Here's the drain. Here's the source. Okay? And now we have a image of a through hole. And this is, they call it a TO92. That just means this plastic transistor. Like when you think of transistor, you think of a TO92. That's what this is called. This is what it looks like. And here, this pinout is DSG, drain source gate. So what you can do is if you purchase the surface mount technology, and that means you're soldering onto these points in here, you'll have these slots are open. So you figure out which one of those matches up with your drain, and then you can use that point as your to put your multimeter on. Or you can solder a wire onto that and use an alligator clip, because there's the idea of, do you want to use when you're gonna actually go through with this process, you can purchase, this is something that's nice to have in your toolkit. So you either have, and you might already have these, a lot of times these come with the multimeter. They'll give you the probes and they'll give you the clips. So when I do it, the way that I like to do it is, for my ground, I will plug in a alligator clip, and that way you can just clip it onto the ground, set it and forget it. And then I use the probe if I'm going to be poking, you know, like in this case, I hard soldered an SMT jfet onto the board, but they gave us the through hole that was still there and nothing was connected to it. So you figure out which one of those represents the drain, and then you take your probe and stick it into that hole of the drain, and that's where you're taking your reading from. So that's how I like to do it. You'll get it set up, get it laid out, turn all the knobs on the pedal down to nothing, to nil, because if you connect your meter to it after it's been biased and then play with the knobs, you'll see that it changes the bias. And the way that you're supposed to bias it is with everything set to nil. And again, all of this stuff is really nitpicky. Like you can just bias by ear. You don't have to do any of this, but me, this is the way I like to do it. So I like to hear what it sounds like when I've got it dead nuts at half of its supply voltage, done properly with everything set right. And then I like to play around with it and see, is there a difference? And then usually I go back to doing it by the numbers. But you test your battery. It's nice to have something right at 9 volts, so then you're looking to pull up just 4.500 on your meter. But that isn't always the case. Sometimes you got, 9.60. So then you got to figure, well, I've tested my supply voltage. I know what it is. Let's divide that in 2. When that gives you the number you're going to be looking to hit on your meter. And then some people will say set your trim pot in the middle of its throw. That's another good piece of advice. But biasing a jfet, it just means 4.5 volts at the drain. If you can remember that, you'll never have to watch one of these horrific videos again. All right, you guys. Pedal PCB is an awesome company. They are operating, they're not so much catering to noobs. So that's me complaining about it. It isn't really a legitimate complaint. If you're building pedals, you should understand what biasing a jfet is, which is, like I said, half of your supply voltage off of the drain of the active that's connected to the tweaker that your jeweler screwdriver is resting in at that time. That's the best way to put it. Now, as far as this pedal goes, I built this mini pedal board today. There's a video on this mini pedal board on my channel. It's a Naga Viper with the full tone fat boost. This is a great pedal. I haven't been down the road with it yet, but my initial impressions are that's awesome. Now the EP boost is what I've been using, and that's 2 jfets. This is 4, so it should be twice as fun. You guys take care of yourself, hug your pets, and peace.